Oops, okay. Goodness, okay, it's forces. I don't know if I've done this video yet, so just gonna go with it. But if I had a box here, and it was sitting on a counter, um, what forces are acting on it? And really, two forces right now. And we're gonna look at this through the eye of F equals ma. So force equals mass times acceleration. And so we're gonna have a downward force. We call this one Fg, or for force gravity. And then we call, there's another force acting on it, and this is force normal. And so the normal force is supplied by the ledge to make sure that the thing doesn't fall, and then the gravitational force is from the earth pulling it down. And this is why we can kind of sit somewhere. And we know that the forces are balanced because it is not accelerating. And because it's not accelerating, the net forces are balanced. And when they're balanced, they're equal. So if we could calculate Fg, we could calculate Fn. Now what happens if I apply a force in this direction? This would be my force applied. And then there would be an opposing force from friction. And so I'm going to call that force opposed, or kind of in parentheses, force friction. Okay. And so in physics, the way my class did it was the easiest way to get a consistent force applied is to just take a pulley with a string and you put a mass on the end. And this mass is going to be affected only by force gravity. And then there's also force tension, which is your force normal. But this is pulling this. The force tension is the same amount as Fg. And so the mass of this falling block is going to be the same force with negligible friction on the pulley pulling on this block. So you can get a really consistent pull or force from gravity. So those are kind of the forces acting on an object.